All right, well, here's part 2 of the pneumatics board project. Hopefully this one should be faster. There's a little bit less to talk about on the board, so it should be faster, but I say that about everything. So let's hop into it, why not? So as you're in the little part 1, we have in the middle is big board right here, just all through hole is the Arduino Pro Mini 5-volt version, and we're probably just going to use the 1-inch, 0.1-inch header pins and just solder directly to the board. Yeah, not much else to talk about there. Right above it, you have your little voltage regulator, a little box knocked out in the silk screen there. I should be able to make this a little bit easier to look at. Well, first let me auto router. Rat's nest it, my bad. View layer settings. Well, this is good enough. Whatever. So yeah. So that's the voltage regulator module up there. Like I mentioned earlier, it wouldn't be too difficult to replace this if need be with a beefier regulator. It is just a fairly, it's just 3 pins, not just 3 pins, regular 0.1-inch spacing, and then the voltage regulator sticks in there vertical. We might consider laying it sideways a little bit if we want to make it flatter. They offer both versions of the voltage regulator, but you can see on either side you have the big old 100 UF caps. Not labeled the actual value because, like I said, it's kind of up in the air. It's not a huge deal exactly what value it is, as long as it's something decently beefy. Below C7, you can see the little reverse polarity diode. I might have forgot to mention that earlier in the schematic when I was discussing the schematic, so I'll just talk about it real quick right now. So it's just a reverse polarity diode, only lets current flow in one direction, just how a diode works. And that just prevents it, so in case somebody switches ground and 12 volts somehow, it doesn't blow up the board. Diode will protect it and keep things from, killing themselves, which is good. Now moving on, right below it, you can see right below that diode, you can see the little Max 232 chip, along with all of its little support capacitors for this and that alongside of it. If you can kind of tell, the routing traces was a little bit janky for this. It was really tight because a lot of the traces were kind of weird, where like the TX and RX, the actual connections, they were flipped, so like they would have to cross over themselves at some point. So like you get stuff like this going on, where these two come straight across from the bottom, but they can't just come straight up. One has to come up a little bit before the other one, so it can loop around it. It was what had to happen, so don't blame me for it. I mean, it just the way things work out. I should have mentioned this a little bit earlier, but yeah, we have a ground plane on the top and the bottom, so that's why you can see the blue bottom traces kind of have the border around them. That's because the bottom ground plane, just a solid plate of copper, top and bottom, makes routing grounds a lot nicer. Not a whole lot of current going through this, so like I said earlier, you don't have to worry about like the ground planes making like bottlenecks here and there, or like the signal level ground and the driver ground getting like one making the other one noisy and annoying, stuff like that. It's not high current, high frequency, nothing crazy is going on. That's what I'm trying to say. Lots and lots and lots of vias. You can see that there's no solder mask over the smaller vias. That's intentional because we don't want exposed vias. And because it makes putting silkscreen over them a little bit, it makes it doable. It's usually not good, like it'll screw up the letters, but it's still there. It's probably still readable for the most part. Lots of silkscreen. Over on the other, well, since we're over here anyways, over here we have the output header, just the 2x8 pin output header. The reason we use P-channel MOSFETs as opposed to N-channel MOSFETs was for this reason, that when I wanted to condense the board a little bit, it makes it really tricky to get this the ground to come in, or to get a trace coming along to this back set of pins, which meant the easiest one to do, since these mounting holes are connected to ground, and these are just oversized vias. It meant that it would be really tricky to get like the 5-volt bus coming along here, and then having N-channel MOSFETs connect the outputs to ground, instead of the way P-channel MOSFETs work, where you connect the output of the input to the positive instead of the output to the negative. There's more technical terms like source and drain, but screw it. Anyways, so yeah, that's why I had to go with P-channel, was because getting the 5-volt rail along behind here around these mounting holes was going to be a pain. P-channel, like I said, not high current. Doesn't make that much of a difference. It's just kind of, oh well, I suppose. Along the edge, you can see a whole bunch of vias just dotted along periodically. It's just kind of good practice that helps keep things nice and shielded, to have your ground going around the edge, and then having vias to kind of enforce that you need grounds along the borders. It doesn't make a whole bunch of a difference here, but like I said, it's just good practice. So yeah, let's jump down here real quick. So let's actually go through the drivers actually. So I'm fairly proud of the way the driver layout went, because I got it fairly compact. Honestly, I was surprised. I did have to bump out the edges of the board a little bit, but that made a lot of things easier. Like, as you can see, the header fits nicely between these two mounting holes and everything. But anyways, so yeah, so the actual driver. So here you can see the input resistors, just 1Ks as mentioned earlier. They have these nice little curves, because I thought that would be pretty. That would be a nice touch, Not that it matters. Doesn't really, like I said, not high speed or anything. And then these all go to the gates. So over here you can see the little SOT23 Q1, SOT23 P-channel MOSFET. And that you have your source, you got your drain over here, and you have your gate over here. And right here is the pull-up resistor, 100K again. And that is connected between the source and the gate. And like I said, that pulls up the voltage whenever the output's not low. And could get into the whole way gates work, but don't feel like that in this video. Yeah. I should have mentioned this earlier, but this big blue bar underneath here is where the 5-volt rail comes in. And that rail kind of runs around to the other things that need 5 volts. Not a whole lot of things on this side that need 5 volts, so the rail only needs to be chunky over here, because this is where everything's getting driven anyways. And then, like I said, your output, let me jump down to the first set. Your output of the MOSFET, where when it's on, it gets put to 5 volts. That goes over to the flyback diode first, and then it has to do this kind of funky thing. Not the best ever, but I mean, in the interest of density, I had to. It goes through the anode, cathode, I can't remember. But one of the two, of anode, cathode, I can't remember the actual terms, of the diode. or at least it goes through the pad, and it goes in the middle of it. It pops through a little via and goes under the board to the bottom, to the outputs. That, like I said, just in the interest of making things nice and compact, I kind of had to do that. You can't really arrange these like sideways very easily to get it so like you have grounds coming in, and it would have been a mess. This worked out nicely, and it shouldn't bottleneck it or anything. It shouldn't be an issue. Now below that you have the output piping off real quick, current limiting resistor, and then you got your little LED right here, right there. And that's along with the flyback resistor or diode. That is just going across to the big ground plane, and then we got plenty of vias all along everywhere to ensure that we have a nice ground connection between the two planes and that everything's working nicely. That's pretty much that. Nothing crazy on that side. Jumping back over here because I forgot to bring it up earlier. Got your big DB9 connector, female. This one too was from the SparkFun libraries, because they sell a DB9 right angle DB9 connector, which is really pretty handy. But yeah, I wasn't a huge fan of how close this hole had to come to that hole, but I didn't feel like moving them a whole lot and making it a weird dimension. This works out really nicely. I can't remember the exact dimension it was, but it wasn't like 0.01259, some silly like number. It was like 3.1 or something, or 3.0 inches from the other hole, and then across it's 1.2, I believe. Or no, it might just be 1 inch. I'd have to count real quick, but I think it might be just center to center 1 inch. I'm not sure. I'd have to double check that. But yeah, a lot of silkscreen everywhere, which is handy for being able to tell where everything's going. Not much else going on the board, like I said. Well, like I didn't say, but it is a fairly simple board. It's not. You got your little drivers, and those are probably the most complicated thing on the board, which they're not really that complicated, honestly. But yeah, you just got a couple little output LEDs for this and that. You can look at the board and kind of get an idea of what's going on. But yeah, as I was saying, it's a fairly straightforward board. Not too much going on it. A couple major component sections that you can break up into little, groups. Not a whole lot going on. Just pretty nice. So yeah, that's about the board. I'm pretty satisfied with how it came out. Like I said, haven't gotten the board yet at this current point in time. It has been ordered and it is in the mail. It's not here yet, unfortunately. I wish it was here so I could see it, because it's fun. Like, look at this, I made this, and you have a physical thing that you made. That's cool, But yeah, I'm pretty proud of it. We'll see how many things are wrong on that board, so might need to order another one. Hopefully not. Hopefully, like I said, it's a fairly simple board, so hopefully I was able to do everything right the first time and everything looks about right. I don't remember the silkscreen overlapping here. I hope it's not like that, because that's a really stupid little mistake. It's not a big deal, but it's silly. I might have moved that on accident at some point after, because I remember going over pretty closely, checking everything, but it still could have missed something. Yeah, not a whole lot else to talk about. So, like I said, this is my first full project in EagleCAD, so I'm pretty proud of it. I'm going to be working on a couple other ones for my little senior seminar class. Hopefully, well, more of those are kind of theory at the moment. When I start finalizing things is when I'll actually send it off to a board house, hopefully, and actually have like a nice finished like ESC looking thing, brushless. Not that I said that, not that I'm talking about the other project right now, but that'll probably be in another video on its own. So I'll keep that to its own. So yeah, not a whole lot else. I don't know how to wrap up videos, which is why I'm just rambling on at this point. So I should do that right about now. So yeah. No.